This is density part 2, and I will discuss some practice problems that you need to be able to solve. So I'm going to walk you through how to solve these, and then I'm going to give you some different problems that you will have to solve on your own. All right, so question number 1 says a substance has a mass of 10 grams and a volume of 5 centimeters cubed. Now remember, the centimeters cubed is from the length times the width times the height. And that's how we get a cubed centimeter. That's where we get the 3 from. All right, so we need to know what the density is. And so remember what our math problem is. Density is mass divided by volume. And so we're going to say 10 grams divided by our volume of 5 centimeters cubed, or 10 divided by 5. And so that's going to give us an answer of 2. So our density, 10 divided by 5, that leaves us 2, and we need to put our units on there. Grams divided by centimeters cubed. That's going to be our density for number 1. So that was an easy one. Number 2, a liquid has a volume of 4 milliliters and a mass of 24 grams. What's the density? So remember, density is mass divided by volume. So kind of tricky there. We have our volume given to us first. And so we're just going to put the mass down first. Remember, it's mass divided by volume. 24 divided by 4. And so we should end up with 6 grams per milliliter. So again, working the problem out, density is mass divided by volume, which is going to be 24 divided by 4. And don't forget to put your units. So our answer is going to be 6 grams per milliliter. Number 3, a large marble is dropped into a graduated cylinder with 35 milliliters of water in it. The water level increases to 49. So this goes back to my first video and talking about what is displacement. So we're going to do some very simple subtraction here. And so the volume of the marble, remember, we're going to take the after level and subtract the before. So 49 milliliters minus 35. And so our displacement, our volume of the marble, should be 14 milliliters or 14 centimeters cubed. And that's the same, those are the same measurements. 1 milliliter is equal to a cubic centimeter. So our answer for number 3 is going to be 14. Number 4, a small rock with a mass of 6 grams is dropped into a graduated cylinder with 20 milliliters of water. The water rises to 23 milliliters. So what is the density of the rock? So we're going to use our very simple density equation. Density is mass divided by volume. And so we had an extra step here. So notice the 23 minus 20. And so we had to figure out the displacement first. So we end up with 3. And then we say 6, that's the grams, divided by 3. And so our density is going to be 2 grams per cubic centimeter. And so even just looking at this density of this rock, I would know that it's going to sink if I put it in water because it has a density greater than 1.0. So for number 4, again, you have the extra step where you say 23 minus 20, and that gives us 3 milliliters. And then we're going to say 6 grams divided by the 3 milliliters. 6 divided by 3 leaves us 2. And that's 2 grams per cubic centimeter. Number 5, what substance will float on water? So remember, the substance that's going to float has to have a density of less than 1.0 because water's density is less than 1.0. And so which one do you think it's going to be? So is it going to be 2, 4, or 0.39? And if you chose 0.39, then you would be correct because 0.39 is less than 1.0 and the density of water is 1. So our option C would be the one that's going to float. And it's not only water that things can float in. So think of like a helium balloon. if you have a helium balloon and you let it go, you're not holding on to the balloon anymore, it will actually float in air. So the density of helium is actually less than the air around it, and that's why it will float. But if you try to blow up a balloon with your own air, your own breath, then it will actually sink because your air, your carbon dioxide, is heavier than the air around it. So helium will actually make the balloons float because its density is less than air. Number 6, an object has a mass of 18 grams and its volume is 2 centimeters cubed. And so what is the density? Density is mass divided by volume, so it's going to be 18 divided by 2. And so our density for number 6 here is going to be 9. 18 divided by 2 gives us 9 grams per cubic centimeter. And just a really quick review of some questions. So question number 1, in the equation, density is mass divided by volume. What does the M stand for? And you would be correct if you said mass. So mass divided by volume. The M stands for mass. Question number 2, only solids, not liquids, can sink or float in water. Is that true or false? And that is false. So you can have liquids floating in water. If you've ever put oil in water, oil is going to float, so it does not sink. Question number 3. A scientist is given a sample of metal of an unknown element. To identify the element using density, the scientist must first measure the sample's what? Is it mass and volume, temperature and mass, or conductivity and volume? And so we're just asking what's the equation for finding density? And remember, that's going to be density equals mass divided by volume, so your answer would be A for that one. Number 4, you can identify an element by using its density. Is that true or false? And that is true. So we will get more into that when we talk about the periodic table, but that is one of the properties, is what is the density of the element. So if we talked about like bricks on a house earlier in our other video, and so a brick of gold, like the size of a brick on a house, that would weigh about 80 to 90 pounds. So gold is a very dense element. Number 5. A marble with a mass of 6 grams is dropped into a graduated cylinder. We have 30 milliliters of water there. Then the water level rises to 32 milliliters. What is the marble's density? So remember, density is still mass divided by volume, but we've dropped the marble into some water. So we've got some displacement going on here. So we need to say 32 minus 30. And so that's going to leave us with 2 milliliters. And remember, it's mass divided by volume. So 6 divided by 2. And so our answer is going to be A. 6 divided by 2 is 3. And so our answer should be A for this question. Last question. A substance has a mass of 10 grams and a volume of 5 milliliters. How would you determine its density? The same question I've been asking. So what is density? It's mass divided by volume. Mass is measured in grams, and volume is either in milliliters or centimeters cubed. So it's going to be 10 divided by 5, or our answer is going to be A. If you have any questions about this material, make sure that you're contacting me through email, and if you need to set up a video session, please let me know. Number 7. A measure of how much space a matter occupies. This just goes back to our vocabulary words. And so this one is going to be volume. How much space does it occupy? That is volume. That is usually measured in milliliters, some type of liter, or centimeters cubed. Length times width times height. Number 8. A scientist drops a rock into a beaker of water and notes how much the water rises. The scientist is using blank to measure volume. So what is he using to measure volume? And that's going to be displacement. And so that's just where we measure the water before and after. Before we put the rock in or other object, and then after. And we do some simple subtraction with those two numbers. Number 9, based on the density of water, 1.0, what sinks and what's going to float? So what two substances could this be? So substance number 1 has 0.92 grams per cubic centimeter, and substance number 2 is 7.88 grams per cubic centimeter. And so we should say that A, we have ice, and then the other one is going to be iron. Number 10, chemists often compare the density of substances to the density of what liquid? And your answer for that one will be water.